Okay, this is the second video and it will show problems 53, 58, and 62. So what I need for you to understand about problem 53 is I am not going to make up any new exponent rules. So if I know how to work this problem over here, oops, that's supposed to be an A. If I know how to work this problem over here, if I know the exponent rules that will allow me to get the final answer for this problem, then I know how to get the answer here. I'm going to use the same exponent rules. Now, truth be told, it does not matter the order you do, like, let's go work this problem. It does not matter the order you do it in. So you could, that is being multiplied. So I could add these exponents and then do big minus little, which is probably what I'll be tempted to do. So I'll end up with 1 over 4a to the 4th. So the first thing I'm going to do is I'm going to multiply the two things that are on the bottom. So, well, I'm sorry, they are being multiplied. So the shortcut rule is that I have to add 1/2 and -1/3, which again, as I've said many times, will require me to find a common denominator that you can use either using your brain or your calculator. So when I multiply f to the 1/2 times f to the -1/3, the shortcut is to add the exponents. I add the exponents and I get 1/6. So this problem is now f to the -1/4 over 4f to the 1/6. So now I need to apply the division rule, which is big minus little, put answer where big is. So I'm going to do big minus little. So that's going to make it turn out to be a plus. Sorry, that's messy. So let me try that again. Big minus little turns out to be 1/6 plus 1/4, which I need to find a common denominator of 12. So 2 12s plus 3 12s is 5 12s. And then you put your answer where your big is. So we have 1 over 4f to the 5 12s power. And again, that's my final answer because my original problem had rational exponents, so my final answer can have rational exponents. Next problem, 58. It's these numbers get people every time. So it turns out that 8 is 6 squared. I'm sorry, what? 36 is 6 squared. So the first thing I'm gonna do is rewrite it as 6 squared. Then I'm going to convert it to a rational exponent and do something. I know it's not going to be a much something, but I'm going to do something. So that's 6 to the 2/8, h to the 4/8, j to the 4/8. So I converted it to a rational exponent and now I have to do something. So the something I'm going to do is reduce them all. It's not much something, but it's something. So, h to the 1/2 and j to the 1/2. So I reduced it. Now if they wanted their answer as a radical, we could say the 4th root of 6 and the square root of hj, because you don't have to put your exponents of 1 or your indexes of 2. Now I think they did not express this final answer. I think they gave the final answer here, which is why I know the book is a little weird how it kind of goes back and forth that way, but I promise you on tests, quizzes, homework, even on the worksheet tonight that you have today, I'm very specific. So let's get the last problem done, which interestingly, because they wrote it as a radical, you had a problem very similar to this 2 nights ago. Like you could have a problem like this on the quiz because we have a radical in the denominator. So we need to remove the radical. So we are going to have to multiply by the cube root of z squared and the cube root of z squared. So we have xy cube root of z squared over, and if you're not sure this is why this works, I'm going to not skip a step here. The cube root of z times the cube root of z squared is the cube root of z cubed. And guess what the cube root of z cubed is? Z. So mission accomplished. We removed the radical from the denominator.